Log base 2 of absolute value of x. Now we haven't seen anything like this yet. We're not taking absolute value of the whole function. We're taking absolute value of just the x. So we can't graph this the same way we handle the other absolute value functions. When you're faced with like an absolute value and you're really not sure what to do, you got to remember that all absolute value does is it leaves it alone if x is positive, and it changes the sign if x is negative. So first thing I'm going to do is just figure out, well, screw that stupid absolute value. If x is positive, it doesn't do anything. So this thing could equal this if x is greater than 0, or equal to 0, really. Because 0, absolute value doesn't change it either. So log base 2 of x will look just like log base 2 of absolute value of x if x is greater than 0. Well, that happens on this side of my graph, on the right side of the y-axis. So I'm going to graph log base 2 of x on the right side of my graph, because that's what it's going to look like. X isn't going to change it all there. And log base 2 of x has an asymptote at 0. So that's still happening. It doesn't matter that there's an absolute value there. Whatever makes the inside of the log 0, there's an asymptote. Okay? And I think we've graphed log base 2 of x, but if not, you can make up an xy chart if you want. Now we're only choosing positive values of x. So for instance, 1, 2, 4, 8. I'm choosing all nice powers of 2. So log base 2 of 1 is 0. Log base 2 of 2 is 1. Log base 2 of 4, 2. Log base 2 of 8 is 3. So this is going to go through these points like this. And there's an asymptote here. So it's going to come up like this and then curve out like a logarithm does. And there you go. So that's what happens if x is greater than or equal to 0. It looks just like a regular old log. But if x is less than 0, what this thing's going to do, check this out, is it's going to turn this thing into the log of the opposite of x. If x is less than 0, base 2. Because if you, for instance, if you plug in like negative 4, log base 2 of absolute value of negative 4 becomes log base 2 of positive 4. If you plug negative 4 into here, same thing happens. Negative 4 is positive 4. Same thing happens. So what we can really do now is we can just graph this function for when x is less than 0, and that's what this is going to look like. Now there's really the trick for this, the graphical trick to remember here is, if you're taking the absolute value of just x, then it makes the right-hand side and the left-hand side of your graph, split by the y-axis, look the same, because it turns all the negative values positive. So for instance, like if 2 gave us back 1, then negative 2 has to give us back 1. Because when you plug negative 2 into here, it turns it positive, positive 2. Same thing with 4. If positive 4 gave us back 2, then negative 4 has to also give us back 2. Because you're taking the absolute value of it. And you can see that here. When you plug in negative 2 here, if we made up an xy chart here, we have to choose negative values for this, really. Because you can't plug in a negative number into a logarithm. Which means that since we're assuming x is less than 0 and it's changing the sign, well, that's also why we're choosing negative numbers. We're assuming x is less than 0. But plugging a positive number in wouldn't make any sense anyway, because you would get, like, if you plugged in 3, you get log base 2 of negative 3. There's not a point there. But since it's absolute value, we can plug in positive or negative. So I'm saying if x is negative 1, you get log base 2 of 1. That's 0. If x is negative 2, you get log base 2 of 2. That's 1. If x is negative 4, you get log base 2 of 4. That's 2. And if log is negative 8, I'm sorry, x is negative 8, you get log base 2 of positive 8, which is 3. And you can see here, it's just mirroring what's going on this side, because it's changing all the negatives to positive, and it makes it do the same exact thing. It's just going in the opposite direction now. So we're still going to have an asymptote at 0, but now it's going to go this way. So we really have two pieces of this graph. One where x is greater than 0, one where x is less than 0. But that's what this looks like. It's a little complicated, but again, remember, all absolute value does is it leaves it alone, which is how we got this right-hand side, or it changes the sign, which is this. That's how we got the left-hand side. And anytime you take absolute value of an x in a function like this, as long as you take absolute value of all the x's, it makes the right-hand side look just like the left-hand side, because it forces all the negative values to turn positive, and they have to mirror the points here.